Okay, so we start with the course. Today we are just going to do introduction and overview of all the topics that will be covering during the course. And also very important, I'll try to define what is a business process, what is business process management that follows from it, and why is business process management important. In particular, I emphasize why is business process management important for IT specialists. Even though business process management is important for business people, it's important for industrial engineers, it's also very important for IT people, and I'll try to focus on the IT perspective of things. So, a business process is basically a big unit of work, right? That consists of things that happen, events. Like for example, this is an event, right? It happens instantaneously. Like for example, you receive a purchase order in a company. By now, you should know what a purchase order is. A purchase order, right? Or an invoice. You receive an invoice or a purchase order. You receive that. That's an event, right? It's an event that carries a document with it. There are activities. Somebody is going to open that purchase order, check it, check the availability, check the customer's details to see if the customer doesn't have some unpaid invoices, etc. Order any products that are missing in the stock and so on, right? And there are going to be decisions. Sometimes we are going to say, well, this part of the purchase order, we cannot handle it now, we will postpone it to later. These products, we will ship them immediately. These products we'll ship them, but later because we'll wait for these other products to arrive and we'll ship everything together. So there are decisions that are taken at some point in time to do something or not to do something, or to do something else. And there are actors, people, or organizations, different organizations like suppliers that are participating in that processes, and resources, meaning human resources, or computing resources, in some cases applications, that are collectively leading to an outcome that is of value to the organization. This is very, very important. All these little events, activities, etc., are happening for a purpose, are happening because we are looking for an outcome that is going to give value for an organization. So if I receive a purchase order, right, I'm going to do a lot of things are going to happen so that I create an outcome that is of value to the organization. What is that outcome?
Profit.
You went a little bit too far. Well, if I had the money for that purchase order, that would be enough. Right, cash. I want the cash for that purchase order. And of course, to fulfill that purchase order. It's a bit more complicated than that. I want to fulfill the purchase order in a way that is satisfactory to the customer. That's one aspect, because I want to have that customer again and again and again. So I'm not only thinking about my current money in the pocket, but also about my future money in the pocket, right? And I want the cash for that purchase order, and I want to do all that at a minimum cost, right? It's very simple: cheaper, better, faster, right? So that's I'm going to do a number of events, not me, but the whole company. Different parts of the company will do a number of activities and decisions to lead to that outcome, which is to deliver or fulfill the order to the satisfaction of the customer, get paid for it, and do so at the least possible cost for the company. That's pretty simple. And there's a theory that every single organization can be split into processes. So you take an organization, it's a very fuzzy thing, an organization, a company. And if you take a company like, for example, Tallinna Kaubamaja, which does all sorts of different things, they have this department store, they have also this supermarket chain, etc., that everything that is happening there can be split into processes. So process is an abstraction that allows you to cover pretty much everything that is going on in the organization in a structured way. And there are two ways of splitting things or two very widely used ways of splitting companies into pieces. One of them is via functions, it's called. Like there's the finance department, there is the supply management, supply chain management department, or logistics department. There is maybe a manufacturing department in some case. There is a sales department, a marketing department, and so on. That's one way of decomposing the organization according to responsibilities, functions, capabilities, right? That is usually used in the context of building a hierarchical organization, hierarchical charts in the organizational chart. And the second widely used way of decomposing a company is processes. In a company, there are processes. I can take you any company, I can think about that, what's going on in the company in terms of, it's a lot of processes that are interrelated. Okay? And there are different types of processes. There is a process that every organization has, and it's called an order to cash process, the one I just spoke about. The process that happens from the moment you receive an order to the moment you get the cash for that order, right? There's actually an even wider process that starts from the moment you have a customer lead, a potential purchase order, to the moment you get the cash, right? Going through the moment where you get the purchase order. So it's even wider, right? That's the most central process in any organization, right? A private organization in any case, but also to some extent in some public organizations too. Right, so think about any company right now. Did you think about one? Okay, don't tell me, just think about it, right? Okay, well, does it have an order to cash process? Who among you thought about a company or organization that does not have an order to cash process? Yes. Which one?
Be specific?
Yeah.
Just simply thinking about some organization which is registered, but there is no action going on.
Yeah, all right. Not the type of organizations I was thinking about, right? Although if you ask them something, they might do it, right? If you tell them, if you repair my house, I'll pay for it, maybe they'll start doing something, right? It just hasn't happened. Okay, so only the organizations that do nothing don't do order to cash. Yeah. Well, it's not quite true, right? In public organizations, it might be a bit different. In a public university, you will have troubles finding what the order to cash is, right? Because the cash and the order and the customer are separate streams. Then the cash comes from government funding, and the customer comes from elsewhere, right? So, but there is a different type of process. I'll get to that. Pretty much any company, including a public company this time, has a process called procure to pay or purchase to pay. It's the dual of order to cash, right? A procure to pay process starts the moment we determine that something needs to be bought. Like, for example, it seems like we're missing shares and we need to buy 100 more shares, right? So that's where it starts. I'm starting an instance of the purchase to pay process to the moment where the product is there and has been paid for, right? So we received the 100 shares and we have paid for it. So it's the opposite of a procure to pay process, of an order to cash process. In every order to cash process of one organization, for every order to cash process of one organization, at any point in time, any instance of this process has a corresponding procure to pay process in some other organization. And the same organization that is doing the order to cash somewhere else might be doing a procure to pay at the same time, right? You know procure to pay processes very well, right? Yes. So you got the point of the build it example, right? It's a procure to pay process that starts the moment somebody determines in a construction company that we need to have a bulldozer, for example, or any plant or equipment, to the moment where the bulldozer has been delivered, returned, and paid for. Right? That's the procure to pay process of this construction company. What a procure to pay process of this construction company? Bear in mind, I'm talking here about types of processes, right? It's like just categories to give you an idea. This is a process and it's of this type, right? So I was saying government organizations do not often have often do not have an order to cash process, but rather have some other process called an application to approval process. So many government agencies are machines at processing applications from citizens who want some service, want to execute a right that they have, or want to get a permit to do something, for example, in the city council, to the moment that application is approved or rejected, by the way. In every process there are positive outcomes, but there are also negative outcomes. So, and when we formulate things, we always formulate them in the positive way. So application to approval. But of course, application to rejection happens too. It's just the same thing. So most government agencies will have that, and definitely a public university has an application to approval process, which is the admission process, right? Every organization probably needs to have an issue to resolution process or fault to resolution process, which starts from the moment that a customer complains about something or reports a fault or a defect in a product to the moment that a resolution to that problem has been found. Or any organization of a certain size ends up splitting their IT services from the rest of the organization, meaning that they specifically delimited, and any IT services department has an issue to resolution process. It starts from the moment that someone finds a problem and creates a ticket, it's called, to the moment that the ticket is resolved by the IT services, meaning that the IT problem has been solved. And insurance companies have a bit of a special one called claim to settlement process that starts from the moment a customer makes a claim because their house burned, for example, to the moment where the claim is settled or rejected, or settled, meaning that the insurance company has paid whatever it has to pay for, and the customer is kind of happy about it. Right. And these are kind of most noteworthy, let's say, common, perhaps the most common types of processes, but by far not the only ones. There are many, many others that we will see as we go along. Right. So now you can think about any organization and say, like, yeah, I can see this process, I can see that process, I can see that process, I can see that process. And there is a methodology that will allow you to kind of more or less exhaustively enumerate those processes and arrange them in a way that, in essence, you have divided the organization as if it was a cake into pieces. Right. So let me just give an example of a business process, an issue to resolution process, just to sort of emphasize the elements that a business process has. So this is an issue to resolution process. It starts because the customer bought a washing machine in some supermarket or store or electronic shop. Yes?
Does an organization have a finite number of processes?
Of processes in the sense of not process instances, but processes. Yeah, I would think so, yes. But the process instances is unbounded, right? There is a process, like Build It has a process for renting construction equipment from suppliers of construction equipment, right? That's a process. And every day, a number of instances of that process are created. Every time the construction company needs to rent a bulldozer, they will say, like, create an instance of the process for renting equipment. So there is, at the very start of it, in every process, a customer. And there is a customer who needs something, sometimes angrily, rarely happily. Actually, sometimes happily too. You can want something happily. That's okay. Right, it turns out in an issue to resolution process is rather an angrily way of wanting something. So that's the first element of a business process. And the customer generates an event for vis-a-vis of the company that is running the business process. In this case, calls a call center to complain that my washing machine is not working, right? And the call center will start by taking some details about what washing machine it is, where's the customer located, when did they bought this machine, and they ask all sorts of questions and enter a document called a claim into an information system, and then perhaps decide that yes, indeed, somebody should go and check this thing. So in some larger organizations, well, it's not the person who answers the phone who will go and check on your washing machine. They will kind of delegate this to a service dispatch center that will dispatch a technician, probably a technician from some other company, because these things are often outsourced to other companies. That technician will arrive to the house, and guess what? Well, the customer forgot to plug the washing machine into the socket. That's a good case. That's a good case, right? That's great, right? So we just plug it and finish. Well, it's kind of not good because we spend time on something we shouldn't have. But I mean, it's not too bad. It can get worse, right? It does get worse. So sometimes, yeah, indeed, the thing doesn't work because the engine burned, right? Broke, kaput, no engine, right? Boom, right? So we have to go and look for a new engine for this washing machine. So the technician will say, yeah, thank you very much. Yeah, I acknowledge that your machine is not working. We will go to look for this engine in a parts store, right? And then, well, hopefully they will come back after a while, after 5 calls and 10 misses, and put the famous sort of replacement engine into the washing machine. And then somebody will then say who pays for this thing, and they are 2 options, either the warranty pays or the customer pays, or actually half and half or some proportion there, and the warranty says, oh, it's not me, right? You know, somebody sort of put some rocks into the washing machine, it was too heavy, and that's how the engine burned. This is not really a burn down that is our problem. So then the customer is not happy about that, right? Because they expected that the warranty will pay for it, right? You always expect that somebody else will pay for it. So there we have what we call a negative outcome. So we had an outcome, the process arrived to fulfillment, but the customer is not happy about it for some reason, right? Now it doesn't mean that we always have to pay for the customer. That doesn't mean that, right? If all we want is that the customer understands why they pay or why we do not pay, and that the process is predictable, that the customer has got their machine replaced or repaired, and that the customer is satisfied that indeed things were done according to the rules and that it was fair, right? So it's fine if the customer has to pay, if the customer understands why they have to pay. So basically BPM is about trying to take these negative outcomes and minimize them, right? It's very simple. Right? So every time you have to turn it into a smile, right? That's what IT is about, isn't it? That's why you are doing IT, because it makes people smile. Isn't it? Except that you don't see the smiles, somebody else will see them, but you are satisfied that the smiles will be there. Every time you go to bed, you think, wow, what I did 3 months ago is making people smile all over the place right now as we speak. So this is great. So what we are trying to do is to turn negative outcomes into positive outcomes at the least possible cost. That's the constraint. In the fastest possible way. Right. So I take this little process, and the problem with this little process is that it looks very simple. That is the problem, because it's actually not very simple. If you start thinking even about what are the possible outcomes of this process, which outcomes deliver value, meaning that added value to the organization or to the customer, and which outcomes reduce value, what you will find is that unfortunately the cases that deliver value, I mean the amount of reasons why you might not deliver value is very high. So it might happen that the fault is repaired without technician intervention. That's actually positive, right? We resolve the problem. Or that the fault is repaired with minor technician intervention and the customer is happy, right? Or or the fault is repaired and is fully covered by the warranty. But unfortunately, it might be the fault is repaired and partly covered by the warranty, and then it might be, and the customer is not satisfied about it, right? The customer did not expect that they have to pay something. It was not communicated to the customer that they had to pay something. The customer believed they didn't have to pay something. At the end, they have to pay something. Negative outcome. The fault was repaired but not covered by the warranty, and the customer is not happy about it. So that's a negative outcome. And the fault was not repaired. The customer got fed up and called another company to get it repaired. That's a negative outcome. And it's very unfortunate I run out of space here, but in the category of negative outcomes, you can go really, really, really down. It's such a simple process. So you have a process where there is some sort of ideal path that looks very, very simple, but in fact, there are so many possible things that can possibly go wrong in the middle. And this is the problem of, one of the problems of software or system development projects, right? That you very often in an enterprise setting trigger a development process, because there is a process or several processes that have certain problems. They are too inefficient, meaning that they consume too many resources or money to be run, or they are too slow, or they are leading to too many negative outcomes, or a combination of the three or all three of these things. And then you have the customer is an organization represented by some people in the organization, and then you have a systems analyst. That's a bit of a problem. And the system analyst arrives there and asks, so what do you want the system to do? And what is the problem? That, well, I do not know what do I want the system to do. I do not know if I want 3 red buttons and 2 yellow ones in the front screen, right? Or in the second screen after the first one. I do not know that. All I know is that, well, I have a process and it is inefficient, I want to make it faster. That's what I know. And then there is a discrepancy because the customer simply wants to make the process faster, more efficient. And the system analyst wants to figure out how many green buttons and how many yellow buttons he has to put in the first screen to go and code those things, right? It's like, that's what I want. And then you let that happen, and what will happen is that, well, the customer will say, fine, put in 3 red buttons and 2 yellow ones, right? And then the customer looks at the thing and starts reflecting, right? Did it solve my problem? And then he says, no, actually, no, not 3 yellow buttons and 2 red buttons. I actually wanted, 2 blue ones and 2 red ones on the other one, right? And then the system developers and analysts complain that the customer doesn't know what they want. The customer changed their mind and changed the requirement. It says like the biggest problem of software system development is that the customer changes their mind all the time and the customer doesn't want to know all the time. Do you think that customers are mentally retarded by nature, by the mere fact that they are customers? Right? Do you think that they are just like that? And it's like, there's nothing to be done. You, smart software system developer, have nothing else to do than live the remaining 40 years of your life dealing with mentally retarded customers who do not know what to do. Right? Why did you choose this profession then? Right? Well, the point is that what the customer wanted was more upstream of what you are asking for. Right? And many projects will not make that effort to go more upstream. Right? Because very often it happens especially in contracted software development. You are being paid on the hour, you are being paid on the feature, meaning how many buttons you put. You are being paid on the contract, and all you need to know is to minimally do what the customer asked for. And so you kind of try to enumerate what the customer asked for and ask the customer, please sign at the bottom. And then now let's go, you're locked in, right? And if you change your mind, you have to pay me more, rather than going more upstream in understanding what the customer wants. And I will postulate, this is my shot at it, but not everybody will agree, that in a business setting, a lot of what the customer wants is in their processes. So if you, as system analyst, can understand their processes, you can actually detect problems in the way the requirements are being defined, much more upstream than if you take this approach that I'm going to go for low-level functional requirements, which means, what should there be, what functions should the software provide. Okay, so I'm going to summarize what a business process is in UML for those who understand it. Business process is a set of collection of events, activities, and decision points where I'll make a decision, whether to send a technician or not, which technician should I send, if there is a part that needs to be replaced, where will I order it from, will I actually order it, or will I ask the customer to provide it, etc. Right? The process involves actors, people, including a customer, particular actor, which is very important, and documents or objects, right? A purchase order, a claim, a warranty document, a customer record, all sorts of objects, data objects, for example, or physical objects in some cases. And all these things contribute to delivering outcomes, which unfortunately are sometimes negative, but we hope they will be mostly positive, right? Types of outcomes. And what we want is that, and the positive outcomes are those that give value to a customer. And that's how we can conceptualize what a business process is. There is another constraint in what a business process is, which we know for more than 20 years, is that, like for example, entering an expense report is not a process. Because at most it makes me crazy. An expense report when you, for example, did a business trip and you come back and you have to do an expense report. Or when you have a project and the project has annual cycles or quarterly cycles and you have to report the expenses in the project and justify them. That's called an expense report. Filling in an expense report, you doing it is not a process because at most it drives you nuts, right? So it is a process. If you lift it a little bit in granularity, most likely above it there is a process. That's a task. Above it there is a process. And the test is that if it makes 3 people nut, then it's a process, at least, right? Then, or at least the other way around. If it doesn't make 3 people nut, then it's not a process, right? So that's the test you can say. So you can say whether this equipment rental system that we talked about in the enterprise system integration course, whether that is a process or not. Most likely, yes, you can count at least 3 people being driven nut by that. Not 3 different types of people. There's a site engineer, a works engineer, and there is a clerk, and then there is a supplier, and there are employees in the supplier side, so it drives quite a few people nut. Right. I think we have kind of done this part, right? You thought about an organization internally, your favorite one, and you thought about a process in there, and you thought about a negative outcome of that process. No? We'll do more of this during the exercise session. Okay, so if we understand what a business process is, if we understand that a business process is a collection of events, activities, and decision points that together aim at delivering outcomes that are of value to a customer, and there has to be at least 3 actors in the equation, then defining BPM is very simple. So BPM is a discipline, just like software engineering, but maybe less broad, that is a body of principles, methods, and tools to design processes, analyze processes, execute processes, and monitor those processes on a continuous basis. There are many ways of doing business process management. There's not like one, single school. I will be pushing for a school of thinking about business processes that is based on process models, which means we first try to understand the process in details and to do process about it for various purposes, to analyze them, to redesign them, to communicate them with the people who are going to be performing the process run. And later on, we will reuse those process models to some extent to automate the process and to monitor the process. all the activities in the business process management lifecycle are going to be done in this way. Right. So that was for what is a business process and what is business process management. Any questions there? Is me giving this course a process?
It's part of a process.
Yeah, well, you can claim that it's driving 31 people nuts. So you say, well, but that was not a necessary condition. That was just, sorry, it was not a sufficient condition, it was just a necessary condition. Is it a process? Well, so far it hasn't been a process because I have been doing all the talking.
It's a task of a process.
Yeah. So, but I would say rather than there is a process for preparing, approving, and delivering a course, right? That starts well before the semester starts, where some curriculum manager determines that this course has to be taught during this period, where the people in the dean's office get to know it will be taught, and therefore they need to schedule it, where then they communicate with the lecturer to figure out how it will be scheduled, and where they open it for registration, where students register to that course, where students come to the lectures, and so on. So I will put the business process more at that level, and delivering a lecture more at the level of a particular activity in a process. Well, I mean, we're not discussing whether there is a process there. We're just discussing at what level of granularity you put the process, right? And because that's the level at which you're going to try to improve it, right? And why will I put it at that level? Because a process has
question.
Yes.
Isn't it an outcome when the students get to know how to do this business process
Yes.
modeling?
I do not get to know, however, that you got it right until things are kind of completed, and we do an exam, and I can see the outcomes, literally, of that, and how many pass, how many fail, how many grade distribution. I can see the student feedback and the student feedback score. We do look at that, yeah, right? And then we can close the thing and say, yeah, this was a rather positive outcome, right? So at that level, yes, it's a visible, tangible, measurable, monitorable outcome. Whereas this thing about like, did you learn something or that? Well, if I could put one of these brain devices on you and say like, send you an electric discharge, and if it comes back the other side, that means that you actually learned something in this lecture, and I could kind of measure it, monitor it, then maybe I will put my process there, and I will start improving my process at that level, right? Every 5 minutes I put you a discharge through your brain, and if it doesn't work, then I raise my voice or I make you stand up, and we're going to improve the process of delivering the lecture, right? So, but because I want to see the tangible outcome, I will put it a level above the delivery of a course. Then yes, it drives many people nuts in this university, and then there is an outcome that I can monitor, that I can see the positive outcomes, I can see the negative outcomes, I can even measure it to some extent, and based on what I measure in terms of positive and negative outcomes, I can go back and improve it. So I will lift at that level where I can do that, where I can see a very tangible outcome. So that's a very important aspect of business process, to identify the process. At what level do you want to put the process, right? In accountancy process, it's kind of easier, right? I mean, you see expense report, yeah, it's not a process, it's only one person, etc., blah, blah, blah. A little bit preparing the annual report of a company. Companies need to write annual reports for for legal reasons and for themselves as well. That's a process. It drives a lot of people nuts because you have to collect data from all over the place, double check it, add it, compile it. The CEO has to write a small blah 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 about how great we did this year, and so on. So that's a process. Okay. So why is business process management important now? If we agree on what is business process management, right? I started kind of hinting that from the perspective of IT people, which are not the only stakeholders in BPM, by the way, it's business. There are people doing business process management, have no idea about how IT works, right? There are people doing process management from an industrial engineering perspective, couldn't care less about how IT works, right? But from the IT perspective, one of the reasons why we do business process management is because we want to understand what the customer wants from a software one level above functional requirements in the sense of use cases and stuff like that. Really one level above, so that we influence it. I'll put it in a different perspective. It's like if very often you build a system in a company setting to improve a business process in some direction. And the first thing you will try to do is to say, yeah, I have a hammer called IT and I can improve by automating it. Automating it is great, it makes things faster. Boom, things happen faster. Well, it turns out that it's sometimes pointless to make something happen faster. If the next task is somebody doing something manually and that person will only do it in 3 days. Do you agree with me? Imagine say, this thing has to be done in 1 millisecond. Okay, now we have to wait 3 days for somebody to actually look at it. That was not very smart, right? Okay, so the first rule in any technology, yes.
If you have a process that's got, say, 3 manual parts and 2 of them can be automated to be instant, you're still increasing the efficiency of the process.
2 of them can be automated to be efficient.
Yeah, so you still have one.
I will show you one case where I will automate 1. And I will show you that was not the smartest thing to do. Just wait for a minute. But I can find you one where you automate 2 out of 3 as well. Right, I'll show you one. And you'll see why. So it's because of this, really because of this. Because if you apply automation to something that is inefficient,
but
magnifies the efficiency.
Microsoft software is really inefficient. Why?
Yeah, I don't think that Bill Gates is talking here for Microsoft. He's talking for himself. Right. Anyway, now he's out of Microsoft, so we cannot blame him for everything that happens in Windows. So your blue screen yesterday was not him. Right. Now he's a separate person apparently. No, he's not Microsoft. Right. I'll give you a hint. There is something better than doing something in 1 millisecond. There's something cheaper, better than doing something in 1 millisecond.
Not doing it at all.
Not doing it. Not doing it. Isn't it better? Right? You're doing something in 1 millisecond where you have to maintain a system that is driving 20 people nuts. How much did you win? If you didn't have to do it. So that's one hint, right? Bill Gates' picture was missing there. Doesn't matter, right? You can see it a little bit, right? Okay. This is 1981 thinking, but it's still very valid, 1982. So the idea is that in an enterprise setting, IT does not or rarely gives you business value. You rarely a company does not make profit by buying 50 Dell laptops. Right? Do you agree with me? It's quite the opposite, right? It's a whole set of things that lead to IT changing the way the company works, and that is what creates value. And I challenge you to find examples of this. Well, there is to some extent when you introduce a technology to automate a particular task, right? Like for example, we were receiving purchase orders in written form and we were copying it into a system, and now we got this scanner with optical character recognition and it can somehow load the purchase orders faster, right? So then you kind of have the impression that, yeah, this purchase of this scanner with optical character recognition integrated with your purchase order handling system yielded value per se, right? But there might have been a better idea was to get the customer to send us his purchase order in XML. Then we didn't need the famous scanner with all these capabilities, right? So if you go one level upstream, you might be able to find a smarter way of doing it. So that's another reason why you have to learn BPM, is because you guys have a hammer, right? I wish you had used it better in enterprise system integration, by the way, but you know, you have a hammer anyway. You have a hammer. You can do stuff. You can make computers respond to a mouse click, right? And every time you have a hammer, you are looking for a nail, right? So you say, well, I need a form to be able to order equipment or to view the catalog of equipment. Yeah, I can do that. Let's go for it. Bang! You hammer the nail, right? That's, I wouldn't say that's not smart. That's smart, right? You are currently ordering construction equipment via phone calls, and now you are going to directly be able to see the list of equipment that a given supplier provides. Click on one and say, I want it. That's great. You will agree with me, however, that nailing this one is less smart. Right? Nailing a screw, well, a tiny bit, yes, right? But then you better turn it around, right? And do you agree with me that nailing this is less smart? Right? Nailing a pin is not very smart, right? It actually doesn't give very good results. And you agree that nailing this is even less smart, right? It's downright not good. Why? That's, you have a problem to nail that one, right? Actually, many people don't manage to nail that down, even without a hammer, right? Okay, talking about hammers, one of the pioneers in BPM is a guy called Michael Hammer, right? Nothing to do with the previous hammer we saw. It's just like hammer, right? People call hammer, right? You know, it happens, right? So he was working in the 1980s at IBM and other places as a consultant. Actually, he was a consultant, business consultant, and sort of saw a lot of things happening that led him to theorize in this theory of like, well, all work in a company's processes, and we should work in terms of improving the business by improving the processes in the business, right? And one of the most famous kind of well-known case studies that he kind of studied was at Ford. So Ford had a procure-to-pay process. They purchased stuff. They purchased a lot of stuff. At the time, Ford was very large manufacturer, super successful all over the place. Things were, in principle, going very well. They had a X percentage of the US market, auto market. It was a big X, right? And they had a procure-to-pay process. They were spending a lot of stuff. Not only that, well, the fact they were spending a lot of stuff, that was maybe normal, but their procure-to-pay process was very expensive. More than 500 people in North America were working only processing purchase orders and invoices. Can you imagine 500 people processing only purchase orders and invoices? That's a process, right? You know, more than 3 people by far. And despite that, still 500 people were working. The process had a turnaround time, also known as a cycle time, in the order of several weeks to get something purchased and paid, right? And they were paying penalties to their suppliers because they were not paying on time their invoices. And they had a lot of error rates, you know, paying duplicate invoices, paying too little, too much, not paying on time, etc. Right? All sorts of problems there were. So you have one of the most difficult problems in business process management, which is to improve all 3 dimensions at the same time. Make things cheaper, faster, and better. Doing one at the detriment a bit of the other one, that's less hard, right? Like improving, making it faster, a bit more expensive. Well, sometimes you just throw in more people and that will solve the problem. But here it wouldn't solve it because it will make it more expensive. And we also have to think about that dimension. Right. And they hire some consultants, IT consultants like you guys with a hammer, not the same hammer, apparently another hammer, right? To look at the process, and they will say, yes, as you said, there are tasks in this stuff, and automation of this task will improve the process by 20%. 20% roughly faster, cheaper, better. Right. The idea, I'll go back later, was to build some expert system for matching purchase orders with invoices and some other stuff, like, you know, like some decision to support system there. But Ford decided not to do it. Why? A, because at the time the technology needed to automate the process was not yet available. There was only COBOL on top of a System 360. Right? You can do pretty much it. It's a Turing-complete language. You can do everything you want, right? B, because nobody at Ford knew how to develop the technology or the solution needed to automate this process. C, because there were not enough computers and computer literate people at Ford to actually use that system. Or D, none of the above. Right. Who says A? Nobody. Obviously, you know, with COBOL and an A360 or RPG, sorry, and an A360, you can do whatever you want, right? B, because nobody at Ford knew how to develop the technology to automate the process. No, because if nobody at Ford knows how to do it, they can hire somebody to do it. Probably the same consultants who came up with the idea. C, because there were not enough computers and computer literate employees at Ford.
I'll do that.
You will take C. You will take C. Well, it turns out that they did have money to buy the computers and the computer literate people as well, right? Or they could train. They had money to train their people and make them more computer literate if they need.
That was in the 90s.
That was in the even 80s. Oh yeah, there were mainframes, 360s, RPG, COBOL, banking system processing hundreds of thousands of transactions a minute at the time already, right? It was pretty advanced. Computers date back from a long time. So it only leaves me D, right? It was because Ford bought Mazda. And then they went there, their executives went there, and they checked out, okay, how are these guys doing, right, this process? And they say, oh my goodness. There were 16 people at Mazda, 16, doing the same work of 500 in North America.
But that's the same people.
How do you think 16 people could do what 500 people were doing?
Do you need COBOL and RPG?
Huh? Yeah, no, actually they did better. We already said it. What's better than doing something fast?
Not doing it.
Not doing it. They were actually, that's the point, they were not doing it.
It was a lean process then.
Then, yeah, it was like, well, we don't do it. Well, how do you do this with 60 people? Well, we don't do it, right? What's going on, right? It's great, right? So, your famous automation solution that will reduce from 500 people to 400 people, where the other guys are not doing it with 16 people, there's some problem there, right? So let me go to the details. So this is how it was working. Somebody wanted to buy something at Ford, and they were calling the purchasing officer closest to their department, right? They were purchasing officers. It's not so much a problem that they were purchasing officers. At the time, people used the phone a lot, and they call, right, we need to purchase this and this and this and that for this particular factory line, right? Or we need to purchase this amount of new desks to refurbish an office, right? Fine. So they will contact a vendor and figure out how much it costs, send a purchase order to the vendor, deliver us this. And then they will send a copy of the purchase order to accounts payable, right? So they will enter it, print it out, send it to accounts payable. So a piece of paper, here's a piece of paper, right? Purchase order. They were sent, purchasing officers all over North America, in Ford North America, were sending those little pieces of paper. Fine. Up to there, no problem, the vendor was delivering the goods. That's good, right? I mean, somebody has to deliver the thing, right? It's good, big packages. You need, big guys to take them on and put them where they have to do. You need trucks, etc. No problem there. You deliver the goods at the warehouse where it was set to be delivered, and they just take them and they put it. They count how many boxes there were, what was in a box. And they write it down on a piece of paper, and they give to a truck driver a piece of paper called a delivery receipt. Delivery receipt. A receipt saying, you delivered this. I testified, right? This delivery receipt, also called the receiving document, was one copy was given to the vendor, one copy was kept at the warehouse, one copy was sent to accounts payable via internal mail. Right? And then eventually the vendor was sending an invoice. God knows when, at the same time, a little bit later, together with the delivered receipt, one, all sorts of combinations at the end of the month, and an invoice did not match one delivery. Sometimes an invoice was long stuff with several corresponding to several deliveries and to several purchase orders. One delivery did not correspond to one purchase order. Sometimes a purchase order contained 10 line items. 5 line items were delivered first, another 5 were delivered second, together with 5 line items of another purchase order. And then there were this bunch of people having 3 piles of documents: the invoice, the delivered receipt, and the purchase order. And then they will take an invoice, and then they will figure out, well, where is the delivered receipt? Okay, we found one here, another one here, another one here. Okay, and where's the purchase order? Oh, we found one here, and one here. Fine. And then they will start seeing, what was delivered doesn't match what was asked. What the price in the invoice doesn't match the price in the purchase order. The delivered receipt says that these items were not delivered correctly, or less than we asked for. Oh, this is a duplicate invoice. We have already paid this part of this purchase order in another invoice, and so on. So all sorts of problems. And then they were calling the supplier, calling the purchasing officer, calling the original guy who did it, calling the warehouse. Are you sure you only received this? Because the supplier is telling me that he actually delivered that. Yeah, no, we are sure that we delivered this. Oh, sorry, we found those stuff in a corner. We had forgotten to actually send you the receiving document for those ones. Here it is. I'm going to send it tomorrow. You'll get it then. Right? So that was what's going on. You can imagine a guy with phone, and then you multiply it by hundreds, right? To resolve one invoice, right? And there were lots of invoices, and lots of purchase orders, and lots of receiving documents. And if something got lost, then we didn't even figure out that there was an invoice got lost, because we only work once we get an invoice. If we don't get it, then we don't even know we had to pay something. Right. So how do you go about solving this mess? Okay, so by the way, the automation part will have said like, oh, this task is very complicated. Great, I have a hammer. I'm going to nail it down. Puff, right. What do I do? First of all, every time we receive a purchase order, a document, or an invoice, we're going to enter it into a system. We're going to enter all the details into a system, beautiful system, right? And then there's going to be the 3-way matching happening. So the system is going to take an invoice, going to look at the purchase order, it's going to match them with a receiving document, it's going to try to match them with a purchase order, and it's going to tell me this one matches nicely, and then, sorry, this one doesn't match. Well, then what happens? Well, I start picking the phone. Why it doesn't match, right? So the automation didn't solve the core of my problem. It solves some problem that I'm not like moving documents around and searching linearly through a pack of documents, but I have a system that does the 3-way matching. So it solves part of the problem, let's say 20% of the problem, but it doesn't solve the bulk of my problem, which is the exceptions. Right? Lots of exceptions. If you start analyzing each single exception and inventorying them, you will go nuts, bananas, completely, right? Actually, nobody even know how many exceptions there were. So what do we do if we have too many exceptions? We kill them, right? We get rid of the exceptions. No exceptions. So where do you think the exceptions are happening here? Having invoices for something I think was not delivered or that doesn't match what I ordered. Where is it happening?
On delivery?
On delivery, right? We have a problem on delivery. So, by the way, once you have matched it, you will send a payment, but that was a detail. So we will adopt some automation, of course, the shared database concept, right? Which at the time, relational databases were becoming very popular. Actually, prior to that, there were Codacil and all sorts of other databases, don't worry. So we will take purchase orders and we'll put them in a database that will be accessible to our accounts payable. That's a small improvement, right? So we avoid duplicate data entry here and here. That's great. I will send the purchase order to the vendor by fax or whatever, and the vendor will deliver the goods. And here is where we're going to deal with it. So have you seen, you have never been in a nightclub, right? Like Tallinn or something like that, or Mazda or stuff like that. But you have maybe walked next to it at some point in your life, right? Yeah, something, because it's on the way to the dormitory, right? Yeah, Mazda is on the way when you go to Ratus the other way around.
Yeah, totally.
Right? Yeah, so there are always two people standing in front of the door, right? And they are G4S, like that, right? So let's do this like a nightclub. We're going to put two of those guys at the entrance, and they are going to say, no pasarán. You know what that means in Spanish, no pasarán? That means like you won't get through, right? So the truck driver will not get through if he doesn't bring a purchase order for every item he is delivering. Right? So he will have to give me a purchase order. Then I put a little guy there saying like, yeah, what's your purchase order? And because I have these famous shared databases, I will not issue a delivery receipt. I will mark that item in that purchase order as delivered. And then if you want, I can print it out and give it to you. Yeah, you deliver these PO line items, right? I can give you a delivery receipt document if the truck driver still wants it. But my main point is that at that point in time, I said, you will not go through, no pasarán, until I find what's the purchase order you are delivering, and I mark that delivered or not delivered. And if not delivered, go back. See you tomorrow. You will deliver tomorrow, right? And this seemingly very small thing is avoiding a lot of exceptions, because I'm not creating a separate document that replicates data here. Replication means inconsistency, consistency means exceptions, exception means a lot of work. And the later you detect the exception, the more work it is, because nobody remembers when the thing was delivered.
So in other words, we're not going to register a receipt of a product if we don't find a purchase order for that product.
We will even kick them back. That's why I needed the two guys like that.
Sure.
Right, yeah. So we will not accept if there is no purchase order. So, if something is delivered and the purchase order was not properly registered, then it will not be delivered. And at that point in time, we're going to, that's a very an interesting aspect, is that you are throwing the responsibility for avoiding the exceptions to the supplier. So if they follow procedure, everything will be fine. If not, they will have a problem. Therefore, they have an incentive not to create exceptions for you. So before it used to be, they were a machine at creating exceptions by just delivering freely and sending you invoices freely. That was duplicate data. I mean, if you did build it, you understand that the invoice and the purchase order has duplicate data. You understand so much that one team even had this magnificent but questionable idea of mixing the two, right? The purchase order and the invoices. No way. They are two different things. But indeed, they contain duplicate data. And duplicate data means inconsistency. Inconsistency means exceptions. Exceptions means work, lots of work. Right? So we are not going to give the freedom to the vendors to send us information that can be inconsistent. If they deliver, they have to deliver against information that is consistent. If not, we have to resolve it at the level of the purchasing order, at the level of the purchasing officer and the vendor, who are the ones who have the right information to resolve it. Accounts payable, here's the trick, we'll check the database from time to time and say, here is a purchase order, or here's this collection of purchase orders that have line items that have already been delivered. I order it, I agreed on a price, I have a PO acceptance from the supplier for that one, and it was delivered. So I ordered something and it was delivered and I know the price. What do I have to do? Pay. There you are. Now there's a trick there. Where's my invoice? Oh, you know that you need invoices in the standard bookkeeping processes to be able to deduct expenses from taxes, right? And the tax office can ask you for one. If you ever create a company and you have expenses, you better keep the invoices, right? Because what the trick here was that then accounts payable will send, for the invoicing purpose, an invoice order. an order to invoice to the vendor, and the vendor will issue invoices against invoice orders. No invoice order, no invoice, right? In the normal procedure. And if you have something that you think you deliver and it's not there, well, it will be easy to say, what is your PO line item? Yeah, it was delivered when? Well, our guys there say no. It's pretty tough guys, so you better not mess around with them, right? So it's easier to track where the problem is. This system is called evaluated receipt settlement, which means that you pay on receipt. Not necessarily the same day, but maybe with a delay of about 1 week or so. So you pay in a very predictable, timely manner on receipt. Everybody knows the receipt was done, was recorded, there was a printout made that it was done, and things are kind of quite orderly, and you eliminated a lot of redundant information that was causing the exception, that was causing the work, and that reduced 75% the headcount in this accounts payable department. Accounts payable is the department within an organization that takes care of paying, which means they receive invoices and they pay. Accounts receivable is the opposite, is the ones who send invoices and they make sure that they are paid. So accounts payable reduced by 75% in terms of headcount, material control is simpler, the whole procure-to-pay process, also called purchase requisition, becomes faster, and we don't have overdue payments because we actually pay in a predictable manner a certain number of days after delivery. So what we learn from that is why automate something we don't need to do. Actually, the article is called Re-engineering Change. Don't automate, obliterate. You know what obliterate is, right? Because in Harry Potter, Hermione does an obliterate spell, in the 7th part, right? Or parts, right? So you know what obliterate is, right? And from there, and many other case studies, Hammer, not the same Hammer I showed before, I mean the other guy, the Hammer, came up with 4 principles which in a way form up one of the bases of BPM, but they are not the only basis of BPM. Of course, it's just one aspect of it, which is that in a process you should capture information once, only once, and at the source. You should subsume information processing work, meaning that's obvious. Right? The first one is obvious. No duplicate data. Duplication leads to problems. Subsume information processing work into the real work that produces the information. So don't have tasks where you are only entering data. That's pretty pointless. Have the person doing work, like for example, ordering a plant. I need to express the fact that I need an order and also entering the data at the same time. Self-service is an example of that. Have those who use the output of the process drive the process. In this case, the output of the process was cash. Cash is given to the suppliers, so make the suppliers responsible for smooth functioning of the process. In other words, give work to those who have incentive to do it. Don't give work to people who don't have an incentive to do it. Don't give work to people who see it as a nuisance to do the work. Give work to the people who want to do the work because, for example, they want to get paid. Right? And if you are doing the same thing in different places, in the case of a larger company, make sure that you treat your geographically dispersed human resources as if they were in the same point. In a way, standardize what different people, if different people are doing the same function in different places, they should do it in the same way. I have an exercise that I will leave it for the exercise session, where we take those principles and we try to apply them. Right. So that's why we should do BPM. I guess by now you are either bored or you agree with me that you have to do BPM. How many people are bored? Nobody, so then all of you agree that we have to do BPM, right? So I conclude that. Right? Okay. So now let's talk about how, okay? How? This is a conceptualization of how a BPM initiative, a business process management initiative, will happen. First of all, we have to identify the process. Huh? You have read 100 Years of Solitude, right? the second sentence, 100 years of solitude, is that when I was a kid, certain things did not have a name, and in order to designate them, one had to point them with a finger. So initially, the processes do not necessarily have a name in a company. You say, and then we have to kind of delimit them, say, this is a process, right? It means from here to here, scope them, give them a name, understand they are a process. So we need to identify the process. Then we can take one process and say, yeah, this process is putting us problem. We will understand it. We call it to discover the process, right? Certainly that work is being done, otherwise the company is not working. So one work done, another is being done, so we're going to go and discover that process. Then we're going to analyze the problems in that process. How can we improve that process? So we get some analysis that tells us how bad the process is, how much could we improve it, where the problems are. Not how to solve them yet, but where the problems are. And then there is a phase where we start looking at those problems and mapping them to solutions. We say, here we have a problem, we can quantify it, it's costing us a lot. Given the nature of the problem, this is possible ways of addressing it. Like, for example, this evaluated deliver receipt settlement idea, right? That's a way of solving a particular problem that Ford was having at the time. And once we have to redesign, we'll produce like a 2B version of the model. This is how we want the process to be in the future. And then, only then, we will implement. And the problem is that oftentimes we IT people will want to skip pretty much this because we don't like to model. This as well, we don't like to analyze, even less, right? We don't want to think, but even less analyze. We don't want to redesign. In fact, we don't like to design, so why will we redesign? So we want to implement, and that's a bit of a problem. And I understand, and this is not incompatible with any agile way of thinking, because I'm not talking here about development processes. I'm talking about upstream things, like not how you will develop, but what are you going to develop, right? So everything I'm saying is not incompatible with agile. When you develop software to agile, great, right? But this is upstream of that. This is not how to develop, this is why and what you will develop. And then you monitor and you control the process, and based on the problems you find while continuously monitoring the process, then you figure out that you have to maybe revise your conception of the process. There are things you think work this way, but in fact they are not working that way. And then you try to analyze again to figure out why are people deviating with respect to the way you think they should be performing the process. So we are going to quickly go in less than 10 minutes on a tour of what are we going to see in the course. The course follows this life cycle. Actually, the textbook follows the life cycle as well, and the course is following the textbook. The first phase is process identification, chapter 2 of the book, where we start enumerating the processes, and we start with very simple truths. Like, for example, in most companies, what is really important, what we call the core processes, are the stuff that sells. We sell things. That's very important to a company to sell things. To deliver the things that we sell, that's very important, otherwise there will be no customers next time to sell to. And to make sure that we have the stuff to sell and deliver, right? So, get materials, add value, sell them and deliver them, right? That's the core of a company. Those are the processes you really want to pay attention to. Those are the processes you really want to understand very deeply. Less important is how do we buy pencils. That's less important, right? This is secondary process. It doesn't deliver core value to the organization. And then there is a whole theory that you can split a company into primary processes that take materials and from the suppliers up to the customer in an added value way. And all these people are contributing to that. And then there is a bunch of secondary processes, also called support processes, like recruitment of people, right? Doesn't give me value to recruit people. Or even IT in a company is a secondary process. For a normal company, not an IT company, of course, it doesn't, the IT is a secondary process. I need to have my IT, but that doesn't really add me value per se. All these are secondary processes. And there is a whole methodology that you will start by decomposing the process into its core process, secondary process, something called management processes, and you will go top-down decomposing those processes, and you will get what we call a process architecture, which is like a bunch of business processes related through different relations, including hierarchical relations. Fortunately for you, this is not covered in this course. It's a very business analysis issue, right? To me, it's a very business issue, and we teach this course for business people, and we give that, but in your case, I'll skip it. One homework less. You won't complain, right? We're going to go straight into, I'll tell you what the process is. I'll tell you, we have this process, right? I'll skip that part of figuring out the process, but believe me, there is an art in figuring out what the process is that is causing the problem, or what the process is that we need to fix first. There's an art to it. I'll give you the process. I'll tell you, here's the process, and we're going to take it from there. So we're going to skip phase 1 and go straight to phase 2. I'll give you a process, and you try to understand it. And to understand it, my proposal will be to decorticate it and to document it as a model using BPM. Box is an arrow model, very simple for you. You'll understand it pretty well, but still you'll manage to get it wrong in the homework. Don't worry about it. This is lectures 2 and 3 and homework 1. Don't worry, the homework is not today. This week, no homework. Isn't it great? You can go and read chapter 1 of the book. Cool. Then we are going to take those models, the process, our understanding of the process in the form of models and their associated textual documentation, and we're going to analyze it. I'm going to show 2 types of techniques. Just for sanity, I'll split them into 2 categories. One is qualitative, no numbers. One is quantitative, numbers. Very simple. And in qualitative analysis techniques, we are going to do blah, blah, blah. But good blah, blah, blah. Because there's bad blah, 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 and there's good blah, blah, blah. Right? We're going to try to do good, structured blah, blah, blah about the process. That's pretty much what qualitative analysis is about. 2 things. We are going to try to identify waste in the process. Waste, horrible. We have to throw it out, right? The things that we have to remove from the process that are not adding value. We're going to identify, decorticate the process to find where is the waste. And the second thing we're going to do is that we're going to take problems in the existing process, so for example, problems related to cost or to time, etc., and we're going to try to trace down those problems to root causes. Often they come from waste, by the way. And that's going to give us ideas of what problems are more important than which ones, and where the source of the problems are in a qualitative way. And we will try to add numbers to it. We're going to define performance measures, like the cost per instance of the process, cycle time, error rates in the process, and we're going to try to use a certain number of techniques, including something called simulation, to get the numbers through. You collect numbers, you simulate, and you get some good idea of what's the performance of the process currently, and if you made a change, what will be the performance of the process if you made the change, according to the simulation in any case, which simulation is not always true, as we know. But it's better than an approximate truth is sometimes better than no truth. Or being approximately right is better than being completely wrong.
Yeah, but the result is also
Yeah. Yeah, there you will agree with that. So we're going to get all sorts of graphs in lectures 5 and 6 to try to understand the impact that a certain problem is having and the potential impact of a change to the process. If you change the process, how much do we gain? And phase 4 is going to be about coming up with ideas for changing, and we're going to see a particular school for doing that called continuous process improvement, where we are going to try to apply different heuristics, techniques that trade off the 4 dimensions of the famous devil's quadrangle. Don't get scared. The devil's quadrangle is a quadrangle where when you pull in one direction, it pulls in the opposite direction. So if you try to make your process faster, oftentimes it will make it more expensive. If you try to make it cheaper, it will become slower. Or if you try to reduce the error rates, meaning improve quality, you actually make it slower or you make it more expensive. And lastly, sometimes you might have the perfect process in normal conditions. For example, an insurance company having a process that is a claims handling process that is perfect when there are no claims or when there are little claims, right? When the number of claims is okay. But as soon as there is a storm and people start putting claims all at once, then it goes bananas, right? That's not the right process. It's not very flexible. As soon as the conditions change, then the process goes bananas, right? And for that, we're going to see 9 heuristics that are going to give us ideas on how we can address the different problems in the process, out of which only 2 of them, communication optimization and automation, are most IT related. The other ones are before you apply IT. So 7 heuristics before you apply IT, and 2 heuristics where you apply IT. That's going to be lecture 7. And then that is going to give us a list of changes that we can do in a process in order to address the problems that we have identified during analysis. And we are going to take that revised process model that I'm going to call 2B, and we're going to put it in a business process management system. There are lots of them. These are the most widely used. And we're going to pick one randomly. Pack! That one. That was a random choice.
That's why it was in red.
Yeah, it wasn't red, it was random. It was random. So it was random. So as you can see, it's just in the middle, right? It's not too big. If I pick a big, you will regret it. And it's not too small. It's somewhere in the middle, right? I might show you some demos of other ones if you want. So every single major enterprise software vendor has one of them, right? And even non-major ones have one of them. So we're going to see Visagi as a BPM, as an example of a business process management system, and we're going to implement process on top of that. And in phase 6, we are going to show how do we take a process that is running, take the data out of that process, and understand how the process is performing, where are the bottlenecks, how can perhaps we improve it, and so on. That's going to be process monitoring and mining. We'll be seeing a tool called Prompt that allows you to do these kind of things. Next week, we're going to talk about process modeling then.